I'm happy to be here. First time in Nordic DevOps days. Happy to see so many of you. But I would like to have some exercise, but from another angle. There are roles, we name it, like we have a platform engineering, DevOps, SRE, IT administrator, sysadmins, etc. I would like to ask you to raise your hands when I name the role, not especially like the title which you entitled in your company, but the role which what you are doing in your company. So how many DevOps engineers do we have here? Okay, how many site reliability engineers? How many at platform engineering? Okay, and how many software engineers? Doesn't matter, mobile, etc. Very good. Front end? Nice. And back end? Oh, Node.js, okay. Good, good. So happy to be there. Managers? Yeah, all the things. Good, and also thanks for organizers for making this happen. So, good. My name is Matas. I'm from Vilnius. Currently, I'm working in Google, but this talk won't be related to Google at all. I'm going to talk about things which I have learned in the last several years, working in various scale-ups in Lithuania. And I have been in DevOps manager role, I have been product owner role for IT services, I have been engineering director for platform teams. So I gathered all experience, different things which could go wrong, and how to improve these things. And I'm going to share these things with you today. Yeah. So the question and topic which inspired me, I have been working a lot with software engineers. So platform engineering provides platforms for software engineers. And it sounds really great. Yes, we have API services, self-services, everyone can do their job, but still, when we launch large-scale projects, applications with high load, there are a lot of things which needs to be done on both sides, yes, on software engineering and on platform engineering, SRE itself. That's why currently there is a huge pattern when a lot of site reliability engineers are doing backend coding, and vice versa. A lot of backend engineers are aware about infrastructure, Terraform, etc. So there is no gap between that, and when there is no gap, sometimes it's not clear who is responsible for what. Previously, we had a talk from our colleague, and she shared the topic from another angle, and I'm going to share from my angle as an IT guy. I would like to ask developers to provide some things for me to operate the software. Good. Most of you, I assume you are familiar with software testing patterns, yes? We have a functional testing, and functional testing allows us to test what our applications are expected to do. Yes, if we have some kind of function which is doing calculations, if we want to have an answer for do some maths, and we have a 2 plus 2, we want to get 4. That's how we are writing unit tests, yes? We define some patterns, and we test if our function is still working correctly. After we complete these unit tests, isolated tests, we go for bigger testing. We test systems, we test multiple features together, etc., but it's always incomplete. We never test everything, because it's difficult to do it, and it's sometimes not pragmatic to do it. We don't have resources. We are sure that these things are working correctly, and we just deploy these things. But complexity comes not only from our way that we don't want to test. In a lot of cases, it is really difficult to test. This is example for a simple application which have multiple features. And these features have feature flags, so it's Boolean, turn on and off, yes? All of you can imagine mobile application, we can just change these settings, yes? Talking about testing, there is a complexity. We have an application with 10 features, and each of that feature can be turned on and off. How many tests we should write for that application to test all these features? So for application with 10 features, we need to write at least more than 1,000 tests. For application with 12 features, we need to write more than 4,000 tests. And it grows exponentially with each feature added to the platform. Are we doing it? From my experience, I've seen that QA will test that feature specifically in that environment. It will work, most probably it will work, yes. But the complexity is increasing with code which we are adding to our platforms. The question is, do we have some options? Yes, the complexity is increasing. That's why we have non-functional testing. So firstly, we said that our applications should do what we are coding to do them, yes? Non-functional testing says that our applications should not do something what is not expected to do. And it seems that it's, yes, we are covered, yes? We test business logic, we also test that something is not going very wrong, and we are good with it. Yes, it's true, but how many companies are doing non-functional testing after each commit to the code base? I assume very few. Very few, and we have a lot of non-functional testing patterns. And if you go to your application environment, talk with backend engineers, I say, hey guys, let's set SLOs for application performance, response times. We said, we don't know, it depends on the databases, etc. It's really difficult to agree with them what should be, response code for application, because it's complex. And are we running these tests after each deployment? Are we running these tests after each time when Chef run on infrastructure? Most probably not. Another thing is about load testing. I assume that a lot of you have done load testing, yes? Are you doing load testing after each application release? Have you ever done load testing for not read-only APIs? Because everyone says, whoo, good, very good. But how much time do you spend after to clean up everything? If you created 10 million accounts in your platform.
We spin up a different cluster for that.
But it's different cluster. Different cluster, different settings, different billing, etc. So it's really complicated. For read-only workloads, perfectly, we can run as many tests as this. Usually we hit some kind of CDN provider, Cloudflare. We test Cloudflare, how good it is at it, and few requests come to our application, and we are good at it. But if you come and say, hey, let's write 10 million users, 100 million users to our database, how are we going to clean up? We don't have space, capacity, etc. So the testing is totally incomplete. Sorry, I'm getting a bit nervous, but okay. Now let's see what could go wrong. So first, Bible for all of us, it is DNS. DNS can fail in various ways. Do we have a Java developers here? Good. Do you know these settings in the bottom of this page? It is Java caching mechanism. This is good setting. It doesn't cache anything. Default setting, it's for cache, it's, I don't remember exactly, 30 seconds, and negative cache is few minutes. So what it goes, you have console, service discovery, good tools, yes, and you have a failure, and console for 2 seconds returned empty response for your API. Java caches it for 5 minutes. You as admin connect to the server, do an S lookup, server shows everything is perfectly working. So you call the application developer, say, what the hell, your application is not working. He says, no, it's network, it's DNS, whatever. So it's really complicated. We never test these things. I don't know test to test such scenarios. We feel it from production. When we have incidents, we do postmortems, we find out the root cause, we have a chef or whatever, some code to fix these things. And each application is different. .NET fail will in different way, PHP will fail in different way, and etc. So it's really complicated. A few years ago, I had a conversation with Android developer in my company. And he said, you know, Matas, to test this new feature which we are building, I needed half a day to travel via elevator up and down. I asked, why? What the hell? I need not perfect network to know if my feature is working. How can I simulate it? Elevator is perfect place. So he was just running up and down in elevator to test if feature and application is really working under such conditions. because it's difficult to imitate. On perfect network, everything is working perfectly. But it is not perfect. We have people from Baltics. I'm traveling with apps in various places. So, okay. Let's look a bit deeper. How many of you are testing responses from our dependencies and if these response types are correctly? We expect JSON and we are getting HTML because fancy firewall just done some various page. What will happen to your application? Or something. We never know because we never test just such scenarios. It's complex and we never do it. The same is with networking. This is part of networking stack. We have two queues there. One queue is responsible for establishing connections. Another queue is responsible for transferring data. If you are an accept queue, it's a very bad place to be. Because what is happening? Your client is connected to the server. You see that connection is established, and your application is trying to send data. But on the other side, let's assume that there is Nginx. Nginx doesn't listen to your packets. And your application is trying to send these packets, and no one is accepting it on the other side. Have we ever tested such scenarios? Because of incident, most probably. Yes, we experienced it via incidents, and then we go to Nginx and said, oh, the worker count in our Nginx is so small, it's only 8, let's increase it. So we are experiencing these problems and fixing things. And it's difficult. Before that, we passed functional testing, after we passed non-functional testing, and here is like DNS. Another crazy thing, third-party libraries. I know very few companies which don't use it. It's normal. We have a good code. We include these libraries and reuse it in our software. There are good libraries available in GitHub. You can read source code, understand what it's doing. And there are some libraries downloaded from FTP server. It's binary, so most probably you can decompile it, but it's difficult to read. And are you aware if these libraries are respecting your infrastructure? Like example with DNS. Until you face it, you are not aware, you just use it. Code it inside, and you just use it. So it's really, really difficult. We are not aware if these libraries are respecting security requirements. Because the company over that library may not even have developers. We outsourced that part because there is not their main programming language. So it's really complicated scenarios. Good, what we have else? Now let's jump out from the technical things to the business things. Last week we had Black Friday. A lot of us, I assume, but not maybe a lot of us, but some of us were told, please just don't touch things in production. We will have a huge load. There's e-commerce integration, etc. Just do your things, do some learning, whatever, just don't touch production systems. Good, I have some time, etc. But the challenge here is that if you don't touch production system, most probably it will face issue because of not touching it. Classical example, memory leak. You deploy application every day a few times. In longest time between restarts have been 3 days over long weekend. Now the business comes and says, hey, let's have a release freeze for 2 weeks. Woohoo, free time, do some learning. In the 4th day of release freeze, you get paged. You don't do releases, and first time after release freeze, when you start something, that the job needs to clean data for the last 2 weeks. Usually it has been doing the very small amount. And it will fail, don't fit window, it will do it during peak time, and you will have incidents. So good stuff, code freeze to test if we are resilient. Yeah, so I have been talking a lot about bad things. Let's see how we can avoid at least part of it. And what we should, as DevOps community, ask developers to do. So first of all, we should have connection timeouts. Timeout is perfect thing to solve most of the problems I have told. We should time out if we don't get answer. We should time out if something is not working. Don't wait for something. If you usually get response in few milliseconds and now past 5 seconds, what is chance to get the correct answer? And it is the cases when developers comes to us and says, hey, can you increase connection timeout a little bit on Nginx or HEProx if something is not working? It happens. And what you should do, say, okay, edge case, let's do it. Have postmortem, let's decrease it later. Because each time when you increase connection timeout, the developer won't care about performance because it works. The next time he came and says, add 5 more seconds, add 5 more seconds, etc., etc., etc. And after a few years, you have 30-second timeout, which doesn't mean anything. If you have mobilized in 30 seconds, user most probably kill that app 10 times. So we should maintain that, and we should ask developers to set these timeouts, connection timeout, request timeout, based on some agreed level. Yes, it's not an easy task. You need to work, but it pays off later. Another thing, if we already timeouted, we shouldn't show the user that, I couldn't acquire tax or paid for something. Let's retry. Obvious thing. Yes, we should retry operations if we timeouted. Most probably something went wrong. We should implement retry strategies because if we are retrying too fast, our dependency most probably will be bombed with our retry requests. Let's introduce exponential backoff for retry. So you retry, wait for 2 seconds, retry, wait for 4 seconds, etc., etc. And then some point after like 10 seconds, you say, okay, I will give up. I don't want to retry because you never answered to my request. I have seen very few companies which try to implement circuit breakers. This is a crazy difficult thing. You need to have backend engineers sitting together for an hour to tune it. Then you should, open or close the circuit breaker for your connections and application. Because with circuit breaker, you're saving your application, but also protecting dependency. But as I said, it's a really difficult thing. We have tools, we have frameworks, but it need to be fine-tuned because if you miss some settings, you will break your whole application. Because circuit breakers work on thread level, and if something is not correctly set it up, most probably you will have a downtime. Yeah. And another thing about failing fast and crashing. After each crash, our application resumes in new state. So it clears all caches, all things around, and it should be more stable. So don't be afraid to crash. We can crash. We have Kubernetes, etc., which now is doing instead of us, yes. If something, in example, liveliness or readiness checks doesn't pass, Kubernetes can kill your pod. So it's the same, crashing application. We also should do some basic validation. As I mentioned before, what happens if instead of JSON, we are getting some TXT, etc. So if you are a front-end engineer, at least do some input validation or whatever. Don't bomb our backends with crazy things which user could input. Another thing, don't crash monolithic applications. So crash or not crash. Because monolithic application usually is doing a lot of stuff. It serves payments, it serves images, it responds to APIs, it provides data for mobile application, etc. And usually it is nothing that could fail all application. Usually parts of your application is failing. Few databases are over that application. So if you crash your monolithic applications, most probably you will decrease experience of the end user over that monolithic application. So that's why you need to invest even more into retries and other strategies. Good. Very good strategy. I love it. A lot of our business and product teams are using feature switching. Yes, we are doing A/B testing. We release a few hundred of users one version, a few hundred of users gets another. We test data, etc. I have seen that release A/B testing mechanisms or release feature switches or feature flags have been used for backend application delivery. Imagine you have a complex project. You need to change a database engine. What you are going to do? you are going to introduce release freeze for your developers because you say, hey, I need to do important migration. I don't want to have new code, yes, in production. So you just deny this all pull request, we are doing something and you are doing your work. I have seen that teams are shipping new code. So you prepare your code with two variants for one feature or for another, for backend feature, for example, connecting to some kind of database or framework. You ship that application with that feature and it works, and you gradually enable it via feature switching. What we are doing with front-end applications, when we are doing canary releases, enabling and for small amount of users, we can do the same for our infrastructure things. Why it is better when doing, an example, I can launch few pods, yes? If you launch few pods, next deployment will make a mess because it roll over everything. With that, you can have the code running. You don't have to have a release freeze for developers. We can ship new software and you can experiment. It's really powerful. You need to invest some time into do proper libraries for your backend applications to work with that system, but it's really powerful technology. And also you have a kill switch. You launch a new job which is running and doing something, and you see that something's not performing. You can prepare new pull request, deploy application, etc., but it will take time. And if you are a page and you are not aware about it, it will take more time. If you have feature switch, you can just shut it down and instantly your backend application will stop doing something. Yes, and another important thing, A/B testing should be done for stable features. If you develop a new feature, launch it to the users, and we are not sure if it is stable, and we are doing some, data collection. So A group get perfect, all good feature, and B group is getting new feature, but it's not working stably, erroring, etc. Can we make a product decisions based on that data? Later we go to the product owner or them say, B group doesn't perform. The results are very bad, but B group have been erroring at 50% rate. Yes, so we already talked about some things. Now we operate software. It should be like de facto thing, logs and metrics. We as a community are very good at collecting metrics for infrastructure, middleware. We have plenty of tools, Prometheus, you named. We can monitor everything, threads, etc. When we need to monitor application, we go to developers and said, hey, can you show the performance metrics? I'm not sure. No. Someone told me that my application is performing based on Nginx upstream latency data. So it shouldn't be like this. We shouldn't monitor our application performance on the load balancer response time data. It's not a good way. A developer should include application performance metrics. At least these three: red, requests, errors, durations. Yes, it is basic observable data for each application. And in addition to that, business metrics. We are doing postmortems. You read a Google SRE book, perfect postmortem, and first question, impact on business. We had incident, we have been not working for half a day, but we are not aware about business impact because we don't have near our data, business data, at least revenue or something. Usually we don't have it, and we say, it might be something like, I don't know. So it's really difficult. So we should ask developers to include business data in our metrics engine for us to work with it in a good way. Logs. Oh my God. Elasticsearch, Kibana, and Python log, multi-line log. You cannot parse it. You cannot understand, it's just blob. Put it. And Kibana is very bad at searching, so maybe I need to have a txt file and do some grep to understand what's happening. So, developers, please provide good logs, structured logs, then we can parse it in Kibana nicely. It's not difficult, but please do it, because usually it's really complicated. As I said, infrastructure logs, we are read at it. And when it comes to application logs, sometimes it's really difficult. Good. A bit additional stuff on how we should observe applications. we shipped our application to production. What is the status of application? I have seen that a lot of companies are providing health or status pages for your application. So you go to the IP address /status or whatever of specific application instance, and you can observe what is happening if applications have been able to connect to caching layer, database, etc., etc., etc. It saves a lot of time. If something is happening, it's just single, curl command or just browser hit, and you can observe what is not working in reality. Because the metrics and the logs usually will make a lot of noise. You will take time to understand what is the root cause, because it will show that there are some errors. The logging engine shows that it is error with that specific application code, but the root cause is connection to the cache. So help pages are very, very useful. And I have seen help pages integrated into the metrics engine. For example, this is example from Prometheus metric endpoint. The developer provided everything for me to operate the software. I can see all the frameworks, versions, etc. When it is useful, log4j.s. Remember? 2 years ago when we had it. We've done crazy shit to understand where we have a specific log4j.s version. Because what we have in Git, it doesn't mean that it's running in production. Yeah? So how to know which of our applications are going to be hit by that security issue? With metrics engine, it is always renewed. We always have updated version. We always know what kind of application version is running in that specific instance. So that is very valuable data. Good. And another very powerful technology, but usually undervalued. HTTP headers. We have 2 types of headers: request headers and response headers. Response header is very powerful to provide a lot of data what is happening with your application. You can observe regions, you can observe web servers, etc. You can check if your application is working correctly, yes? We can add additional data like caching status if the cache was hit, etc. And that data is also to be logged in our logging engine, so we can check it later. It is very useful for migrations. An example, you are going to migrate from one compute engine to another, from one cloud to another. It is global application. You hit that application. How do you know which kind of service or provider served your application? Just do it with headers. You code the header in application. That application, hey, I'm running in Google, I'm running in Azure, I'm running in AWS, and the response headers will provide us with that data. For QA, it will be very useful. Another technique is for request headers. We can do routing to correct backend based on header in application, yes, when we pass request. I have seen things with teams saying, we have that staging environment, yes, under different domain name. So we launched application, QA is starting to do the checking, log in with social media button, bam, error. Why? Because in social media, that new domain is not registered. You go to the Facebook, Google, etc. You add setup, but your confidence is lower. What else I'm missing because of its different configuration, different CDNs, different domain names, etc. With headers, you can play in almost the same infrastructure, but route at the lowest level, at the last level. Yep. Okay, so that's it for today. Just for a few things what we should ask for developers. So first of all, let's have timeouts and retries. Secondly, ask them to provide metrics and logs in correct and good format. We should have some kind of health and status pages for us to troubleshoot and maintain software. And we can ask them to add scaling capabilities via feature switching. That's it for today. Thank you.
Thank you, and very insightful talk. I expect lots of hands with questions. Should I ask?
You should retry.
Okay.
As a very bad actor, I would be very enjoying you listing all the versions of software and dependencies that you use in your public page, how you protect that information from me?
Usually slash metrics are denied to access from internet. So it's usual pattern, and these metrics are not exposed externally. You just collect it internally and observe in the internal network. But that pattern exists, that a lot of companies are exposing such metrics to the internet until we found it out, because that's how the Prometheus is working.
If I kind of find no, security guys help me. When I make one application query the internal network, can I get metrics?
It depends on your policy. Yeah.
You mentioned feature flags. How to explain to developers that they are needed if they would like not to have them?
Just say that we are going to have maintenance for the next 2 years. We are doing platform migration, and the business will force them to do. No, but the feature switching is used by developers and by us engineers. And for them, it's a safe choice to ship a lot of software, which is now, bulletproof. We can experiment in production with these settings. So a lot of developers, don't like to break things. It's natural. I don't want to make my business bad, yes? So with these technologies, usually we are very flexible to adopt it, and there are a lot of open source platforms for that soon.
Okay, more questions.
Thank you very much for the talk. I would rephrase the question about the feature flags is how do you persuade the developers to remove the feature flags when the feature is stable?
Yeah, so I have been investigating that topic. So the question is really tough. We have plenty of dead code because of these features have been released. So what I see modern feature flagging platforms are doing, we are connecting with your GitHub repositories. We understand based on the code what kind of feature it is, and we can say, okay, you haven't touched that toggle for the last 2 years, do you still need that feature? And we can implement some additional scripting, internal, project to have a proper cleanup. But that is a challenge, very, very true.
Last question for Kalle.
Usually developers or like anybody needs a carrot and a stick to do something. The stick, is it easy? You approach via, I don't know, managers, leaders, whatever. What kind of carrots do you think would be useful to use to persuade developers to care even a little bit about non-functional requirements? Because usually they don't give a shit, right?
Mm-hmm. We can take practices from industry, for example, Google. Be on call together with us. One of the practice. Let's sit together. If we done something bad, let's sit together and solve it. And sooner or later, it adopts. But it's not like, one answer how to do it, but exactly you need to work with them. So.
Okay, and let's ask you the same question I bugged Ave. How many engineers does it take to solve a race condition?
All of them.
Thank you.
Thank you. Thank you.